Hi, everyone. Building and successfully running a global active-active architecture is hard. In this session, we will address only one specific use case, an online store processing relational data with heavy reads and fewer writes. DynamoDB is typically used to replicate data across regions with eventual consistency. This allows replicas to diverge, eventually converging into the latest updated value. This conflict resolution strategy is not ideal for relational and transactional data requirements. For example, let's imagine two users, Mary and John, both ordering the last item of a given product, but Mary ordering from Ireland and John ordering from Sydney. If they order exactly at the same time, then both requests will be successful, and the available number of items will go from 1 to 0 on both regions. Upon replication, however, the last write wins, so all good, until the warehouse tries to fulfill two orders with only one item in stock. Aurora is an alternative to ensure data consistency. In Aurora, writes are only done at the primary region and then replicated to secondary regions, while reads are done in any region. This pattern is known as read local, write global. But more interesting is a feature called write forwarding, which allows writes to be done on the read replicas on the secondary regions and then forwarded to the primary region to be persisted and replicated. But life is complicated and real-world online stores can be messy, with multiple microservices using purpose-built databases and managed legacy ERP databases running on EC2 instances, and dependencies on on-premise databases and third-party software-as-a-service providers. With limited technology offers, project implementations tend to be limited in scope, and customers end up cutting corners to deliver under time pressure. As a result, a number of projects fail to meet expectations, and the investment and trust on multi-region architectures is lost. To address data consistency across the data stores of the multiple microservices that compose a modern application, we will look at the CQRS pattern. In this pattern, write requests are processed by a saga that calls domain-specific microservices and then writes the normalized version of the data into DynamoDB. Subsequent read requests are done on the normalized objects directly from DynamoDB tables in the same format required by the API endpoints. By adding DynamoDB cross-region replication to CQRS, you can split CQRS into regions, with the primary region having both write and read API endpoints, while secondary regions only having read endpoints. That is similar to the read local, write global pattern from Aurora Global Database, and it's a recommended strategy for multi-region deployment. Likewise, you can have write forwarding, with write requests being forwarded from secondary regions to a write API endpoint on the primary region. Also, for customers running data mutations that interact with on-premises and third-party services on specific regions, it's more effective to process those mutations on those regions. But this chain of dependency on distributed services over a single synchronous request raises relevant performance challenges. For that, we will look at the reactive version of CQRS. This version of the pattern adds an event bus before the saga, decoupling the microservices in the distributed transaction and resulting in not one, but multiple updates to the denormalized data object in the DynamoDB table during the life cycle of the transaction. Read becomes more complex, though, because the duration of the transaction is now unknown, and the object may change multiple times during the transaction. Then, how can client applications know when to query the results? The solution is to notify client applications on every update. For example, by using the subscriptions feature of AppSync, invoked whenever a CDC event is received as a result of a DynamoDB table update. When these ideas are applied to Ireland as the primary region and to Sydney as the secondary region, then Route 53 will route Mary and John to their local APIs, and AppSync will query and subscribe to the normalized data from the DynamoDB global tables. Finally, API Gateway and Event Bridge will handle writes, but only on the Ireland region. If the workload in the Sydney region fails, then Route 53 will divert John to Ireland. So John will only notice an additional network latency on reads. If the workload in the Ireland region fails, then both Mary and John will be able to read, but not write. And this will happen for the duration of the outage, or until Sydney is promoted to the primary region. There's a reference architecture with further details, but even better is to see a live demo delivered by my colleague Ralph. Take it away, Ralph.